Hello there. This is a continuation of a series of videos which I have been creating around big ideas around AI for kids to learn, and it helps the kids understand AI through a structured curriculum. And it came through this AI conference. The research actually came through this AI conference, which happened in 2019, and these universities were part of that. So big idea number two, and if you want to look at big idea number one, go look at the other video. Big idea number two here is that agents maintain models of the world. So agents, when I refer to agents, agents are intelligent agents or artificial intelligent systems which can do something with things around them. And when they do things around them, they have to maintain a representation of things around them in models, right? In models which they can use for computing. So typically, intelligent agents have software. Models are also represented in representations within software or data structures, and they deal with that. So just for kids to understand the concept, the most important thing is that there are a lot of models out there. One of the models, if you look at it, I have a representation of the city of Austin, downtown Austin. And let me use my pen here. And this is in a visual map and produced by Google. This map is representing the model of the city, right? So that's one way of explaining what a model is. A model is some kind of representation of something, typically something which has physical attributes being, in this case, mapped out into a map. The other example which I use is, how do you represent chess games? Chess games are represented by these 2D, 2D board where you have the white pieces and the black pieces, and specific moves are showcased here with showcasing that there's a specific state of that chess game. So the state, understanding a state of a chess game is also important, or understanding state of a model is also important. Now, without further ado, the curriculum looks like this. So if you look at the grades 3 to 5, they have to understand models, and I typically use paper. I like using paper a lot because it gets them, drawing and getting their creative juices flowing. But I use them to ask, you live in a house or an apartment, draw a floor plan, and it gets them to represent that in a model on a piece of paper. Then I get the kids working on simple representations in computer programs. I use different tools for that. MIT has a great tool. You guys probably know that. It's a drag and drop coding platform, Scratch, and we use sprites and canvas to represent the world. And then there's some kind of feedback we use with using the touching block to query it. That's a lesson we use to represent models. Then we do a little bit of what we call a decision tree, and very lightweight decision tree. Initially, draw it out. How do you go take a specific path within the tree and use some kind of inferencing, and then we create a game, right? A game based on questions you can ask, like for example, how to guess an animal based on questions. The software will ask you questions, and the machine will figure out what that animal is. That's those are the lessons to experiment with some kind of modeling. And I will use the same inference algorithm for grade 6 to 8 to create a decision tree so they understand decision tree and logic. And then we'll go into a little more advanced concept called knowledge graph. There's a video which I'll ask them to watch and see how Google maps its knowledge into knowledge graphs. And then once they understand that concept, they can, draw their own knowledge graphs. We don't go into, more detail than that, but we also ask them to represent, I'm talking of the sixth graders to the eighth graders, we ask them to use arrays for data representation and then ask them to actually draw that room out. In this example, I would use them to draw out a floor plan and actually use arrays to represent coordinates, and then draw a room out, right? Draw a room, a floor plan, very much like the grade 3 guys were doing, the grade 3 students were doing. I will ask them to do that. So it gives them, representation, how you store data, how you represent that data. Again, a model, right? So grade 9 to 12, a little more advanced. We still go with the Google's knowledge graph if they're jumping straight into this program, and teach them concepts around lists and dictionaries. And I'll teach them a little bit of algorithm around breadth first search. This is more around how do you navigate a graph, and depth first search, and how do you retrieve objects quickly. How do you make decisions? For example, I'll use examples like, if I have a tree or a graph which represents, how airplanes go across multiple cities, how do you think, what's the best way to figure out how much time that an airplane takes to go from this city to that city, things like that. So those are examples I would use. And that's idea number 2 in terms of curriculum for kids.